Okay, welcome back. So let's discuss the digitalization aspect. So the expected learning outcomes of this upcoming lecture is that you should be able to describe digitalization elements relevant for PSS design. Number two, explain the benefits of digitalization, using digitalization elements for PSS. And then thirdly, describe challenges, opportunities, and barriers for digitalizing PSS. In this lecture, I will go through some useful pieces of information first, and then thereafter I will introduce some of the research projects that we have carried out in Sweden, and then I conclude with the challenges, opportunities, and barriers for PSS. So I showed this slide earlier, but I didn't explain the aspects about digitalization at that point. So now I'm talking about that particular aspect. So we do recognize the digitalization is one important sort of aspect for why PSS are demanded and expected. So that's highlighted here, and then because of that we see different opportunities for PSS design. For example, through digitalization techniques, it's possible to better understand user needs and also risks and values, right? We can sort of collect data, if possible, from user behavior and so on. Right? And then we can obtain, use, and manage product-related data and information. Typically, industry talks about product lifecycle management software packages, and that kind of business relates to this PSS design opportunity. Huh? And then, by having larger sets or broader sets of data and information, it's likely to be able to apply more holistic systems thinking and also systems design. In the previous lecture, we talked about the aspect of systems design in PSS design. So meaning that characteristic of PSS design can be supported by using proper digitalization techniques. No? So upcoming few slides will show you some sort of useful information, and when you apply the learnings from the lectures and tutorials for your own work, let's say your own example in this week, I think the coming slides will be very useful for that work that you are conducting. And of course, you should be able to get access to the upcoming tables like this. So the first table explains to you different types of data that are relevant for PSS design. The first one is product specification data, meaning that you address a product and data, various data can be attributed to the product, features and so on. And secondly, usage data, meaning the data about how the product is used, and then usage result data. Usually, when after product is used, some results are obtained. Service configuration data. Obviously, in the PSS context, service is part of the offering, and how the service agreement is made and so on is also a very relevant information. maintenance data relates to the repair, maintenance, and so on of the product in question. Okay? Any question? I think they're very straightforward. No? And then the continue to the data types. Another type is about infrastructural data. It's about the systems that support the product and services in question. Whether sort of environmental data, locality data, and human attributes, human state data, meaning the product users, the data for about the users. Okay, so these data types are relevant particularly for PSS design because I'm referring to this table taken from a PSS relevant paper. So now data is useful, obviously, but to be precisely put, it's potentially useful because data must be sort of used to extract useful information. And the information typically is used in the engineering management engineering processes and also management processes. In the previous lecture, we discussed the design process. So that is located in the second layer of the pyramid here. So now here, interesting thing is when it comes to PSS design, it mainly concerns the engineering and management processes as well as how the value can be created through the such processes. So these two first layers of the pyramid are the sort of target of PSS design. Data is in another layer, in the bottom layer of this pyramid, and typically, academically speaking, if I may, computer science is the discipline that handles well the data and the information. So here now we see again the opportunity of using two different disciplines to help companies in trying to improve the PSS design. Huh? So now, yes, and also AI, especially with generative AI, provides unique opportunities for doing PSS design in a different way than what could be possible before. So now, regarding the technologies, meaning how to use and how to address and use the data that I explained earlier. This table is also taken from a PSS paper, and it's a bit busy table, but simply speaking, it relates to how to connect different objects in terms of information, data and information as well. That's the first category. And then the second category is how to store the data, where to store the data, and so on. The last one is, okay, regarding analysis, how to analyze such data collected and stored. So in that way, I think it's quite straightforward to understand what are the essential technologies needed for PSS and PSS design. And I think if you look at the right-hand side, it's quite straightforward. What are the enablers? I mean, obviously, you need sensors, actuated connectivity devices for the IoT. It's obvious, and so on. All right? So this, I think, sort of basic categorization is also, I think, useful for you to conduct the application of different learning outcomes to your example in this week. So now, putting us in the PSS context, it is important to have this perspective, life cycle perspective, from the product point of view, right? The product life cycle typically consists of these different phases: part production, manufacturing, meaning assembly of different parts and assemblies, and transport and use together with service and maintenance, and after use treatment and management. Typically speaking, traditional product-focused manufacturer focuses on this area. They get components supplied by their suppliers, and then they assemble those, and they ship the finalized product to a customer. As I said in the first lecture, moving the box. No? And then thereafter, the company's responsibility is basically over. No? So what this setting incentivizes manufacturing companies is that optimize this system. Huh? And obviously those manufacturers have been providing other services taking place in outside the system, for example, repair and take back and so on. But simply put, they are not the core activities if you follow this system. But now, there are opportunities that have emerged, for example, reuse and using the products again and again, and also remanufacturing and also recycling. Regarding the digitalization, a lot of data has been collected from each of these phases. Huh? And here, what I want to say to you is there is a big opportunity of applying this broad perspective, which allows a company to see the connection, or at least to analyze the correlations between different data sets. Each of the sets comes from the different phase. No? To see the connection. For example, if a company finds a specific pattern of user behavior from this phase, that information belongs to here, but that information can be analyzed in correlation with the data sets coming from design, which doesn't exist here, but the manufacturing and also part production. Okay? For example, if another example is if sort of unexpected malfunction of a specific component happens in the use phase, that component, particular component, might have been inappropriately produced in manufacturing. If a company has stored such data of each production batches, then that information can be effectively used to help technicians in the service phase. So these types of activities can be done only by this broad perspective and also analysis of data and information coming from different phases. So this is, I think, very relevant in the context of PSS design when it comes to digitalization. It's not really about the technological aspects and also physical feasibility, but to see this opportunity with a broad perspective. Huh? So if I should have implemented animation on this slide, but you should have seen the major part of the ice. You know what I want to tell you. So this is the major part of the iceberg can be seen if you have a broader perspective, right? Okay, then another big table is about digital capabilities, especially in the PSS context. You can maybe focus on the second column, middle column. These are the questions that can be answered if you have a proper digitalization system, and also if you have a PSS design in mind. First, who is using the product at a specific time, etc. So regarding user, and which specific product instance and product model. And the next one is, where is the product located? It's about geographical location. The next one is about time. What's the point in time? Huh? And then the last one in this table is the use intensity. For example, how much is, for example, a car used? How many times per unit of time is the product used, right? What's the condition? How is the product working? Why is the product used? Regarding the purpose, I think you probably studied and learned different cases of industry regarding the digitalization. And I'm not sure about your exact experience, but thinking about my experience from co-working with different companies, it's quite surprising to see that these questions can't be really answered because of the lack of digitalization system or the lack of motivation. We don't have to know this. We don't have to answer this, right? So it's quite surprising to visit company and ask the status of regarding these aspects. And for example, it was quite surprising when we were working with, let's say, a vehicle manufacturer, and then there was no specific system that records the purpose of the vehicle per customer. So, but depending on the purpose of the vehicle, the deterioration of the vehicle quality differs significantly, of course. No? In that case, a vehicle is used in some cases in, let's say, on the seaside, let's say in a sort of, for example, fish market and so on. And the other, in other cases, it's more sort of a restricted environment, in-house environment. So these two different conditions, quite significant. No? So to get the information and also use that information is quite powerful. Huh? Prediction and also adaptive related to remote control and optimization prescriptions, and also the autonomy, how the product can act by itself and so on. So now related to a circular economy, because I need to explain this for the coming slides. In this week, at least from my side, I would recommend to refer to this definition for a circular economy. It's about technical products. But more in general, a circular economy has another aspect, which is biological cycles, like foods and forestry, etc. But those things are not in this course, from my point of view, and therefore, in this lecture, at least, a circular economy is about technical product, and it's about restoration of the products and products and components through maintenance, reuse, refurbish, remanufacturing, beside material recycling. So this is what I will be talking about circular economy. And the upcoming 2 slides explain how digitalization can contribute to realize circular offerings, circular economy, motivated business offerings. In many cases, they are relevant to product service system. So you see on the left-hand side business goals, for example, connecting different actors, and the second one is about understanding product and customer behavior, etc., etc. The third one is product reliability, lifetime extension, and so on. So this table shown on this slide and also on the next slide explains to you how different activities based on digitalization can be really help each organization in terms of the company's goals. So I think this table, also in the next slide, is again useful when you apply the learning outcomes in your example. Okay? So, and looking into practicality, typically each company is limited in its resource, and of course the goal must be set at a certain level, and this is taken from publication by others saying that there are different levels when services, support services are provided, and typically company gradually implements such supports, and then in this case the company can start level 1 and gradually climb up the ladder. These are, I think, these levels are quite straightforward too. For example, the basic level is about creating digital manuals and also using smart devices and so on. Then the next level is supporting the customers when it comes to diagnosis of the product and so on. So this sort of piece of information is also, I think, useful when you apply to your case. Is it clear so far? Okay, good. So from now, I want to share with you some of the research and innovation projects that our team has been working on. This slide shows sort of architecture for the software aimed to support companies to deal with data related to the product life cycle. And in this particular research and innovation project, we planned to develop such software building upon an existing commercial software for the PLM. Typically, if you look into industry, commercial software vendors have their own software packages. They claim that they are useful for PLM, product lifecycle management. But I would say typically there are development opportunities for the PLM part, especially compared with what I explained so far in this lecture. So we saw a development opportunity here as well. We worked with a specific vendor, and we saw an opportunity, especially the additional input and output with designer, such as lifecycle cost data, revenue data, and also as an input from designers, like, for example, maintenance data, maintenance planning data, and take-back plan, and pricing model, and so on. Those are what I have been explaining so far in my lectures related to PSS, which are important. No? So this is just one example of us having seen the development opportunity when it comes to software for really supporting companies to exploit the PSS design opportunities. And I'm sure that if you look into software industry landscape, I'm sure that you will see the development opportunities as well. This is a very good business opportunity, by the way. Okay. Next one. One of the innovation projects that we have been running is about how to use artificial intelligence in the context of lifecycle engineering. You can recall the pyramid slide, which I showed in this lecture. Typically, AI or computer science looks into the quality and performance of the algorithms, how fast a given algorithm can solve a given task, and so on. That's their typical problem. But when it comes to PSS, we want to improve the lifecycle performance of the product and other things. And usually we see a gap between the two disciplines. And then that gap we wanted to fill in this research project. And then this picture shows our vision for how to use artificial intelligence in a better way for a better lifecycle engineering. So at the bottom of this picture, you see different activities or different lifecycle phases. For example, product design, service design, product assembly, production design. So all of these are lifecycle phases. And I think you remember one of my earlier slides showing different lifecycle phases. So I think you remember how they are sort of connected to each other. So typically, traditional lifecycle engineering thinking builds upon a sort of serial series of different lifecycle phases. Design, and then manufacturing, and then use, and then service, blah, blah, blah. But we think there is a big opportunity, not by seeing such a sequence, but seeing a collection of different activities. Because, for example, when maintenance and repair takes place, data can be collected and then that data can be immediately used to service design right away. So instead of waiting for the analysis and capturing useful information and applying that information to a next product lifecycle generation, but we see an opportunity to use the data and the information in a much more fast and also effective way, so that these different lifecycle phases will be sort of much more organically connected with each other, helping different phases with each other. So that's how we see sort of future lifecycle engineering could be. And interacting with those lifecycle phases is intelligence that consists of artificial intelligence as well as human intelligence. Because obviously we believe that human beings must be involved in important decision making. So therefore we see, we put business intelligence at the top, right? And if comparing the new way of doing lifecycle engineering compared with the traditional lifecycle engineering, we can say that, as I said before, the time for implementing a certain change is much faster, or to be precisely, that will be much faster if a company implements this vision in reality. And also, another highlight is the accuracy of the changes made in such a digitalized environment will be much higher than right now, because of the sensors and also analytics of the data coming from those sensors. The analysis can be made for individual products, instances. So that's why we see potential of the much more increased accuracy in making any change. Okay, and we looked into different research works related to application of AI technologies to different life cycle phases. We found that there are quite a few research works that have applied different AI technologies or data analytics methodologies applied to different phases. So there are different research works ongoing, but in reality, meaning that when it comes to the application of these AI into practice, we see a big gap. And I think this is an opportunity for research and also practice. So, talking about the different life cycle phases, where product and components and parts are circulated from the middle of use or end of life to the upstream of the value chain. But we know that for those physical flows, especially for the reverse flows to happen, we need to have information flows as well. For example, let's say if a service technician faces a product in the use phase, the technician needs to know the history of the specific product, for how long the product was used and how the product was used, in order to make judgment for the appropriate second life of that specific product, right? If the product is used like for a very long time, then that may be not useful for the reuse, for example. So that means in order to make this anticipated physical flows, we need to have associated information flows as well. But looking into the literature, we found a number of research works that were applied to specific life cycle phases, but this life cycle perspective is typically not used. So meaning that each research work has looked into either, let's say, production data to improve production, use phase data, improve use phase, and so on. But this sort of the application of information across different life cycle phases is very rare, even research. So that's why we say that we make this kind of statement that very little work has been done so far, and this is a big research opportunity. For you to have a better understanding, one of the examples that I mentioned is like this. So they looked into the data set coming from the car sharing service in Germany. They looked into the 35,000 drives by about 2,000 users, and it's a potentially very good data source, no? And then they analyzed the data set in order to improve the energy efficiency and also the personalization potential depending on the users. And then they used machine learning, and the paper shows the credible results, meaning that the benefit is there, exists, no? But the point I am making based on that publication is that that information and sort of learning should be also used in product design, so that the product design is adjusted according to the data coming from the use phase. So this is the example that I wanted to tell you. So another case from our project is that we access to the data of maintenance reports. So we work with a production facility. They have a number of production machines, and there are, let's say, several dozens of maintenance engineers dedicated to maintenance activity. And from time to time, problems occur from different machines in the production line. And for each problem, obviously they fix the problem, and the problem and also the reaction that solved the problem is recorded in a certain computer system. And record contains free text description of the problem and the problem solving. And then we analyzed that free text. And then we managed to produce such knowledge graphs that looks like this, based on the free text plus the ontology given to the system. The ontology means something like this. So basic concepts used in this maintenance work and so on that were developed together with the AI experts and the practitioners in this factory. So this is, I think, very useful. So nowadays, text data is, well, ubiquitous. You name it. No? Consumer reports and sentiment reports and so on. That can be used to derive more organized way of representing data, like this, for example. But I think this data has a big potential to be used in, for example, design of the machine, in this case, and design of different offerings when it comes to sort of consumer reports rumors, and so on, that can be used in design stage 2. So I think this example shows such potential, and I think you can easily point out, there is a potential in different manufacturing companies and other types of companies. And I think this is the last one from our own research and innovation project. When it comes to application, there are always challenges related to the organizational setting, different contexts, and so on. Then we looked into implementing condition-based maintenance as a product service system element. And then we asked 3 different companies, and we collected different challenges and also existing solutions. And the challenges are widespread in the organization and the context, and the challenges might be related to information as such, people, technology, and the system. And the message I'm conveying here is when you think of applying a certain digitalization technology, then there will be challenges. And the challenges are not only about the technologies as such, but also the context and who will be using the technologies and who will be receiving the results of the application of the technologies, etc. So please have this kind of thing in mind when you think of the application into your example. And the last, I think, 2 slides show such opportunities and also barriers for small and medium-sized companies when they aim to implement PSS design with digitalization in mind. If you look at the left-hand side, I think these are quite understandable, especially on the context of small or medium-sized companies. Some are about digital strategy, some are about internal and operational organization related issue. There are opportunities and barriers both. And I'm quite sure that after graduation you will be working sometimes, at least, with small or medium-sized companies. And you need to think about these aspects. The last slide. The theme could be the ecosystem, the whole ecosystem, and also the capabilities of the people involved. I think this is the last slide. So one message I want to once again convey to you is typically when it comes to use of digitalization, so this is the sort of motivation. So we see an opportunity to improve the efficiency. We can do this faster, from 1 hour to 1 minute, or even 1 second. So this is a typical motivation. But when you apply this thinking to each single element of the process and system that you are in, typically you have a risk of getting trapped into sort of, let's say, efficiency trap, meaning that even if you realize this improvement of efficiency of each single step, you may not reach the better system or better improvement if you look at the system as a whole. So I think PSS design gives you such a sort of thinking and also perspective to keep the broader one and trying to improve the whole system. I think with that, I want to open the floor to take any question that you may have. Yes, please. Yeah, yeah. Microphone.
What is meant by digitalization specifically in this context? Because we see many things getting digitalized, so processes, products, what exactly?
I see. In this context, so I didn't use the term digitization, which means basically changing the yeah. For example, digitizing data as such. Ne? So that is a fundamental one to realize digitalization properly, as you know. And digitalization here involves the implementation of such digitization into a given context that involves different organizations, like work procedures, workflows, and so on, so that certain benefits can be obtained. So that's how I would say for digitalization. So in the context of PSS, PSS can be envisioned in different ways, and some of them can't be realized without effective digitalization. For example, providing services depending on the user behavior. That can be envisioned easily, but without getting the data of customer A and analyzing that data, that sort of adaptive service can be provided. No? So that is, I think, an easy to understand example. Yeah. So other questions? Yep.
So you spoke about organizational setting, right?
Yeah.
So to understand that, how did you understand that? Was it through just research, or did you go for what is already in practice? How did you understand the organizational setting of an organization?
Were you referring to the second half of this?
Yeah, second half.
Okay.
You were talking
Yeah.
about the organizational setting, right? So how did you understand that? Was it just through research or through data from a particular organization?
Yeah. The organizational setting includes different aspects, right? And we typically communicate closely with the practitioners involved, meaning, for example, in the case of the production machine failure data analysis, we first aimed to understand existing systems and how these systems are used and who are involved. Those kinds of information pieces are collected and also taken by the researchers. No? So through the such interaction, we aim to reach a better understanding of the organization. No? Yeah. Yep.
So, sir, earlier also we talked about that information that we can collect in different stages.
Yep.
That can be used and implemented in other places to overall benefit. But what if the cost of that implementation is much higher? Because for SMEs, it is like the probability of implementing that infrastructure will be much higher. So how do we analyze things that okay, implementing this thing will benefit us a long term, so maybe we should have the burden to invest in that infrastructure?
Yeah, very good question, I would say. And my response would be, so coming back to this thing, there are a number of opportunities that could be taken, and obviously each opportunity provides different return on investment, so to speak. And then obviously SME and the like is limited in its resource, and therefore they need to make a rational choice. And I think PSS design offers a unique opportunity by providing a wider selection of such opportunities, meaning that not starting from what is possible, but starting from what is desired, what is expected, what is wanted from a broader system perspective, and thereby making it possible for even an SME to choose a better one among them. So obviously the resource is limited, and then they want to choose higher return on investment items. But I think have this in mind, no? So that's, I think, the message. With that, yes.
With that, we'll leave for lunch, but before that, kindly mark your attendance.